So today we have unknown angle proofs that we have to work on. We've done proving vertical angles are congruent in lesson 11. And we've done that if two parallel lines are cut by a transversal, the alternate interior angles are congruent. So using these two facts, we're going to prove that corresponding angles are congruent. We already know that, we've talked about that, we've done it numerically, but now we're going to prove it like the ancient Greeks did. So what we first need to do is you need to sketch a diagram here, right? So you need to have two parallel lines, okay? So we'll call this one AB and this one CD. So you should be following along. And then you draw a transversal that goes across it. And we'll have that angle 1 and angle 2. Right? They're corresponding angles, so we need to prove that they're congruent. So our given information is just going to be that AB is parallel, this is the parallel symbol, to CD. And you need to prove that angle 1 is congruent to angle 2. To help us do that, we'll add in another angle here. We'll call it angle 3. So, step 1 is always your given. So AB is parallel to CD. That's given information. We also know that since I added that angle 3 there, that angle 2 is congruent to angle 3 because vertical angles are congruent. Step 3, we could say that angle 1 is congruent to angle 3 because if lines are parallel, the alternate interior angles are congruent. So if lines are parallel, alternate interior angles are congruent. Okay, well, now we know that 2 is equal to 3 and 1 is equal to 3. So 1 has to be equal to 2. You could use substitution here. And where the substitution is basically we know that 2 is equal to 3, so therefore we can bring the 2 and put it here, and now we have 1 equal to 2. So now we have a bag of tricks that also includes corresponding angles are congruent. It's kind of a little annoying, I guess, because you've already used these theorems, right? But now you know how to prove a theorem just like a real mathematician would. Okay, so on the next page, on page 60, oh wait, let's just go back to page 59. On the bottom, right, you have vocabulary. Proof is an explanation of how you come to a conclusion, and you use known statements. So if you know that certain angles are equal, and you can prove it, and you can have a statement next to it, then you're good. Theorem is what we just proved, right? We proved that corresponding angles are congruent, so we don't need to do it over and over again. We can just use this theorem now, and we don't have to do it anymore. Okay, so exercise 1, here we're talking about the theorems that we have. We have vertical angles are congruent, alternate interior angles are congruent, and corresponding angles are congruent. What happened to... Uh-oh. I thought I was recording. Are you kidding me? Oh, oh my God. Sorry about that. Okay, so we're still recording. Okay, that's why. Sorry. Excuse my French there, kids. Okay. Alright. Alright, so now on page 61, okay, we're going to prove that the sum of the angles of a triangle is equal to 180. Okay? So, in order to do that proof, you need to draw an auxiliary line through A that's parallel to BC. Okay? So, you're given that, we could call this JK. So you're given that JK is parallel to BC. You could say draw an auxiliary line. Or you could say a given in this case, okay? All right, so now you basically have a bunch of angles. This is like a transversal right here, right? And so we have angle 1 here, we have angle 2 here, and we have angle 3. Well, those 3 angles are all on one line, so therefore they add up to 180. So we have angle 1 plus angle 2 plus angle 3 is equal to 180. Okay. So now we know that, okay? We also know that angle B, so this here is angles on a line. Okay. We also know that angle B is equal to angle 1. It's congruent to angle 1. Okay? And that's by alternate interior angles, right? Well, we also have angle C is also congruent to angle 3 for the same reason. Okay? If you look here, right? These are alternate interior angles. Over here, angle B, alternate interior angles. Okay, so we have step 1, step 2. Step 3 is like a combo. Okay, and step 4, we can just say now, we can go back to step 2 here. And instead of putting in angle 1, we could put angle B. Instead of putting in, we would still use angle 2, okay? And we'd still add in angle C. And that's by substitution. And that proves that the sum of the angles of a triangle add up to 180. Because we proved this angle, and this angle together all add up to 180. Okay, so now what I would like you to do is turn your workbook to page 63A. We're going to skip the other ones. If you want to do them on your own, you can. Okay, so let's go to the next page. Okay, and this is a Regents question, and it looks similar to what we just did. Okay, So they draw a line through through C that's parallel to AB. Okay? And so it's saying through point C, draw DCE parallel to AB. And this is, the reason is auxiliary line. Okay? The next step says that the measure of angle 1 is equal to ACD. So here's angle 1, and here's ACD. And the measure of angle 3 is equal to BCE. Okay? And the reason for that is they are alternate interior angles. So alternate interior angles are congruent. Okay? And then the last step, let me just change the view on this a little bit. Oh, okay, well, we'll just have to leave it. Okay, so then step 4, right, you have that ACD plus angle 2 plus BCE is equal to 180. Well, those angles are all these 3 angles, and they are just on a line. So the reason for that is angles on a line. And the last step, well, ACD is equal to angle 1, and BCE is equal to angle 3, so that is just a substitution. This question will be on your quiz, so you really need to make sure that you understand it and study it. You can ask the sub to replay any part of this or backtrack it. Okay? All right. Have a great day. See you on Friday.